So now that you know what a polynomial is and how to find the degree of polynomials, we're going to talk about adding and subtracting them. So our learning goal for this section, I got ahead of myself, I wrote it down before I started recording. I will add and subtract polynomials. Pretty straightforward. This is going to look really similar to stuff you did in 6th and 7th grade because it's just really combining like terms. So to start off with, let's just look at combining, or let's look at adding polynomials. So let's start with this example. Negative x squared plus 4, that's one of our polynomials, and I want to add that to 3x minus 9. So when I do this, I can add it vertically, or I can add it horizontally. I know that people tend to like adding things vertically. It can just be a little bit easier to see visually. So in order to do that, what I do is I write out my first polynomial. But notice that I don't have an x term here. So I'm going to put in just a big gap between the x squared and the 4. And I'm going to add that to 3x minus 9. And you see that the 3x goes in that gap. And that's because I don't have just an x term that's being added to that 3x. Just like I don't have an x squared term down here to be added to that negative x squared. So from here, I'm going to add these terms together. I have negative x squared plus 0. So that's just negative x squared. I have 0 plus 3x squared, so that's a positive 3x. And here I have a 4, and I'm taking away 9. So this is going to give me a negative 5, or I'm subtracting 5. So vertically, this is really easy to see visually. You just have to remember that you can only add like terms together. This guy is squared, this one isn't, so you can't put those together. These are constants, so they can go together. If you wanted to do it horizontally, then what you would do is you would group the like terms together, which in this case my only like terms are the 4 and the 9. But so I'd have negative x squared, I have 3x, and then I have 4, and I'll write that as a negative 9. Those can be grouped. These two don't have anything to group with. So negative x squared plus 3x and 4 and negative 9 is subtracting 5 or adding a negative 5. So I get the same answer either way. I prefer doing it this way. I just think that it makes a little bit more sense. It's easier to see. Let's try another one like this. If I had negative 3q squared minus 2q plus 7, and I'm going to add that polynomial to 5q squared plus q minus 4. So let's try doing this one vertically. You can see they each have a q squared, a q, and a constant term. So it's actually a little easier to write them out vertically. So that's going to be where my 5q squared is going to be plus q minus 4. So then as I do this, I have a negative 3q squared and a positive 5q squared. So together that's going to make a positive 2q squared. Here I have a negative 2q and a positive q, so that's going to make a negative 1q, or just subtracting q. And then a 7 and a negative 4 make a positive 3 together. So when I add these two terms together, I get 2q squared minus q plus 3. So again, it's really just combining like terms. It's very, very easy, but it's also very, very easy to make a mistake because we're going to have positive and negative numbers in there. So you just want to be really careful with those and make sure that you're not losing negatives anywhere. Subtracting polynomials is not any different from adding them. Again, we can do it vertically or we can do it horizontally. You want to be careful though, because remember that subtracting is really just adding the opposite. And so what I would be doing is instead of subtracting a positive w squared, I need to think about it as adding a negative w squared. So what I'm going to do is I write it out vertically, just like before, but I'm subtracting now, minus w squared minus 8w plus 2. And what I'm going to do is I'm going to keep the first line the same, but I'm going to change this to addition, and I'm going to pick the opposite of each of these. So this is now a negative w squared. This is a positive 8w, and this is a negative 2. So if I change the signs of each term, then I can change this to addition and follow my rules from before. I have 2w squared. I'm taking away a w squared, so I have a w squared left. I have 3w, and I'm adding an 8w. That makes 11w. I have negative 5, and I'm taking away 2 more. That makes negative 7, or subtracting 7. And again, I could do this horizontally as well, where I just group the terms together. But again, I would need to make this a negative w, a positive 8w, and a negative 2 before I group them. And I should get the exact same answer. Just one more example of this. 7d squared minus 8d plus 6. And I'm going to subtract a 3d squared plus 4 from that. Notice here, I have a term with a d. This guy doesn't have just a d. So when I stack them vertically, I want to make sure that I leave a space where the d goes. That's a plus 4. So change this from subtraction to addition. So 7d squared minus 8d plus 6. This becomes a negative 3d squared and a negative 4 because I'm adding the opposite. 7 plus negative 3 is positive 4d. I'm taking away 8d, but I'm taking 0 from that, so that's negative 8d still. And 6 plus a negative 4 is 2. So this will simplify to 4d squared minus 8d plus 2. I'm going to give you 2 on your own, one sum and one difference. So the first one, x squared minus x minus 2 plus 7x squared minus x. And then number 2 will be a difference, p squared plus p plus 3 minus negative 4p squared minus p plus 3. So again, you can do these horizontally or vertically, whichever one you like better, but I personally prefer vertical. It just makes it a little easier to see visually that I'm matching up my like terms. So go ahead, pause, and try these. So I've rewritten these vertically. You may have done it horizontally, but we should get the same answer. X squared plus 7x squared is 8x squared. Negative x plus a negative x is negative 2x. And I'm taking away 2 and nothing else, so that stays subtracting 2. So 8x squared minus 2x minus 2. Now for this one, because it's subtraction, my first step is going to be to rewrite it as adding the opposite. The opposite of negative 4p is positive, or negative 4p squared is positive 4p squared. This is negative p, so I'll change it to positive. And then I'll be subtracting 3 instead of adding 3. So the opposite of each term. P squared plus 4p squared is 5p squared. P plus p is 2p, and 3 and a negative 3, or 3 then taking away 3, is just 0. So that right there is going to be my final answer for that particular problem. This next example looks a tiny bit trickier, but it's really the same idea. We need to match up our like terms. So when I stack these vertically, I'm going to have my s squared terms first, and then I'm going to have my terms that have the s and the t next, and then the t squared term. And when I stack them vertically, I keep them in the same order. So s squared minus 2st plus t squared. So I still keep my like terms together. I have s squared and s squared, so I have 2s squared. 5st, take away 2st, is 3st. And a negative t squared and a positive t squared make 0. So my final answer is just 2s squared plus 3st. Here's another word problem with this polynomial that should look familiar. The polynomial negative 16t squared minus 30t plus 200 represents the height of a penny after t seconds, and the polynomial negative 16t squared minus 5t plus 100 represents the height of a paintbrush after t seconds. If you were to look in your book, the example 4 is pretty similar to this. Basically, you have a building. Somebody is standing on the building on the roof and drops a penny. Somebody else is standing 100 feet below that and drops a paintbrush. And these are the polynomials that represent those situations, or not just drops, but throws down. Because remember, these look like this, negative 16, t squared plus VOT plus SO. So in this case, our initial velocity, that negative 30 means it's thrown down. That 200 means it's starting 200 feet above the ground. For this guy, our initial velocity is negative 5, so it's also thrown down, just not as fast, but it's only starting 100 feet above the ground. So our first step is to write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So to find the distance between them, I need to subtract them. So that would be negative 16t squared minus 30t plus 200, and I'm subtracting negative 16t squared minus 5t plus 100. Now, to make this so I can do it, I need to change the subtraction to addition and add the opposite. So negative 16t squared minus 30t plus 200 stays the same. I change to addition. This will become a positive 16t squared. This will become a positive 5t, and that will become a negative 100. So my t squared terms have opposite coefficients, so that's 0. I have negative 30t plus 5 is negative 25t, and 200 minus 100 is 100. So this expression right here, negative 25t minus 100, represents how far apart the penny and the paintbrush are after t seconds. So then for part B, where it says what's the distance between the objects after 1 second, I just have to take this simplified expression right here, put in 1, and let's see, this is, oh, I'm sorry, that's a positive 100. Positive 200 minus 100 is positive. So that's a negative 25 plus a 100 is 75 feet. So after 1 second, the objects are 75 feet apart. And that should make sense because the penny started higher, but it started with a higher initial velocity. So it's going to potentially catch up to that paintbrush. It's getting closer to the paintbrush as they fall. So that is the whole lesson on adding and subtracting polynomials.